In this video, we're going to make the computation for some eigenvalues, and we'll start out with a matrix A. And this is just an example of a 2 by 2 matrix. In the next section, we'll look at larger matrices. So to find the eigenvalues, we want to make the computation A minus lambda I, and then we'll look at its determinant to make sure that that is a singular matrix. So first we set up A minus lambda I. So that would look like 1, 1, minus 2, 4, minus lambda times the identity matrix for a 2 by 2 matrix, which would look like this. And I'm writing out more steps than I need to here, really, but I want to make sure that it's perfectly clear where all of this is coming from. When we're done with this, we will be able to just jump right to our A minus lambda I form each time. So we'll multiply in our lambda times I. And now we can make the subtraction. So A minus lambda I is going to be 1 minus lambda, minus 2, 1, and 4 minus lambda. And what you'll notice, of course, is that as I multiply lambda times I, we get a similar form every single time, which really amounts to just subtracting the lambdas off of the main diagonal in our original matrix A. And this is generally where we jump to. We don't need to write out all these steps here in the middle. We can just set this up every time as we go forward. But at least it should be clear to you now where that setup is coming from. Again, we want the determinant of this particular matrix to be equal to 0 to ensure that it's singular so that we get non-zero solutions. So let's take the determinant of A minus lambda I, and that's going to be equal to 1 minus lambda times 4 minus lambda minus negative 2. And a little bit of cleanup there gives us lambda squared minus 5 lambda plus 6. Again, we want to set this to 0 now to make sure that the matrix is singular. So we have that lambda squared minus 5 lambda plus 6 is equal to 0, which in this case amounts to a pretty simple factorization. Here we get that lambda minus 2, and the second factor is lambda minus 3. So we have two eigenvalues here. One eigenvalue is 2, the other eigenvalue is 3. And that's how we can find eigenvalues for a 2 by 2 matrix.